Today I'm going to be unboxing this Tronxy Moore 1 clay 3D printer. Before I got into all this 3D printing stuff, I was a huge pottery and ceramics nerd. So I've been wanting to get my hands on one of these clay 3D printers because it's a perfect intersection of two of my favorite hobbies. So it takes packets of clay like this and extrudes it into shapes just like a normal 3D printer does. But these parts can be fired in a kiln at over 1,000 degrees Fahrenheit in order to produce high quality stoneware. I want to give a huge thanks to Tronxy for sending this printer over to me for testing and review. I'm really excited about this printer, so let's open it up and see how it works. So let's go over all the parts here. We've got a power supply, the Tronxy Moore 1 3D printer, a bag of miscellaneous tools, nozzles, and connectors, Teflon tape, and a putty knife, a big gearbox, a lead screw, this housing, and some tubes that are used to load the clay and extrude it out towards the printer. It looks like there's an additional direct drive extruder on the print end itself, which will help boost the clay's pressure and get it through the small nozzle. In addition to the print bed that's already on here, we've got another print bed and 2 bags of clay that are ready to use. It also came with these instructions, so I'm going to be reading the manual to figure out how to work this machine. So it says to remove the 4 screws attaching this aluminum piece to the gearbox. Then I need to install the lead screw, and the reason we had to take off the aluminum plate is that I'd have to run the stepper motor in order to screw this screw in all the way, but by taking that plate off I can just spin this on. Now we'll just put this aluminum plate back on. Now I'm going to need this bag of screws, this plunger, a half-liter plastic barrel, and one of these pneumatic couplers. So I just thread this plunger onto the tip here and then secure it in place with one of these screws. Looks like there's 2 sizes for the threads here. You're just going to want to use the one with the smaller threads, and that'll go on just like this. Alright, so after tightening it with the included wrench, it looks just like this, where the nut is flush against the lip there. This plastic piece seems to thread on okay, but the threads in here are a little bit sharp where they're cut. So ideally I'd like to smooth that out just to make sure that these plastic tubes last for as long as possible. If you have a Dremel with a wire brush at home, all you need to do is come in here and smooth out the start and end points of all these threads. So if you want to be smart about this, you should probably take this aluminum piece off because you run the risk of getting some metal shavings inside the gearbox if you do it like I just did. Now these threads are much smoother and I can run my finger along here without getting caught or hurt. You want to avoid cross-threading this as much as possible. So a good way to ensure you're not cross-threading is to push down while unscrewing, and then you'll hear a click when it falls into place, and then screw it on. Then we just need to put these 4 screws in here. Now it's time to install the print head. For this step I just need to take 2 of the short screws, put them in up here. Then I can take one of these tubes and I'll attach one end over here, and the other end will be plugged in to the extruder over here. It looks like the only thing I'm missing at this point is the clay. So when you're working with clay, it's important to get the consistency just right. So I'm going to squish this clay around just to make sure that it's a nice homogeneous texture. It's also critical that you get rid of any bubbles in the clay, which is why I'm leaving it in the package while I do this. If you're mixing it by hand, unless you're using the right technique, you can actually incorporate bubbles into the mixture. It looks like they put it in a bag, inside of another bag, inside of some plastic wrap. And you gotta be careful with this stuff because you can make a bit of a mess with it. This is a lot wetter than normal clay that you'd be working with. It's almost like mud. So I'm gonna go ahead and start loading it into the tube. They say to roll it into a shape that's smaller in diameter than the tube, and then just kind of drop it in there. Alright, I'm gonna load my first clay cartridge here. Look at it go. Oh gosh. I think I was trying to extrude too fast there. So you could just 3D print with this. I'm going to go ahead and make my first little piece here. This is actually pretty fun even without the whole 3D printer aspect of it. I mean, you can just be the 3D printer here. This printer also comes with some nozzles of different sizes and an SD card. So I'm going to put the SD card in and run some test prints. This allows you to run the extruder forwards and backwards, and if you tap this item down here, this lets you choose between running the extruder that's on the print head, the extruder that's pushing the plunger and getting the clay fed into the system, or you can run both. In my case, I want to run both to get everything primed and ready to print. So I'll just press the plus button here, and it's going to start spinning everything. So this is going to be slowly pushing clay through the system, and we should see it coming out of the tip here eventually. Now if you want to feed more rapidly, you can tap on the number in the middle of the screen and enter a faster number. It was at 0.7, I'm going to set it to 5. The stepper for the clay supply is skipping steps right now, so it's clearly up to pressure, but for some reason clay isn't coming out of the end here. So I'm going to pause this and try and figure out what's going on here. Again, when I remove this pipe, you can see it's got plenty of pressure because the clay is just shooting out of there, but there might be some kind of blockage inside of the hot end, or I guess it's not really a hot end. I can feel something moving around in there after tightening that screw, so maybe that did the trick. Oh! Looks like we got some clay coming out now. That's good. We'll let it run for a little bit until we get a nice steady stream of clay coming out. I'm either trying to extrude too fast or this clay is too thick of a consistency. So I'm just going to take all this clay and put it in here and get it to a more liquidy consistency. So this is my toothpaste consistency clay, and I'm going to load it into a cartridge here. I don't know if you can hear this, but my printer has a little bit of a squeaky noise going on. Not sure what's causing that, but I'm going to add a dot of oil up here, a squirt of oil. Yeah, that fixed it. So if you're having a little squeaky issue, just add a little oil to this joint up here, and that should resolve your problem. And I'm ready to load my new clay into this machine. To change clay canisters, I just undid the screws that hold this metal cover on. And then I'm going to want to draw the plunger all the way back to its rearmost position. I'm going to change this from both to cartridge only. I'm going to set the speed to something really high. We'll go with 40. And then I'm going to run the extruder in reverse. And if we look over here, you can see that the plunger is being drawn backwards. Once it gets all the way to the back, it'll start skipping steps because it can't move back any further. And at that point, you can just tell it to stop. This takes about 3 minutes to pull it all the way back just because of the large gear reduction in this gearbox. Alright, and while that's happening, I'm going to unplug this tube and unscrew this piece. There we go. Don't get your finger caught in here, that would really hurt. Alright, so that was it hitting the end stop. You don't want to leave it running like that for too long. I'm going to put this metal cover back on. One thing about this tool that bothers me is that these wings stick out too far. So when I'm trying to tighten this, it's constantly bumping into the side here. Alright, so I just finished chopping it up with a hatchet, and this should work a lot better now. That's more like it. Now I'll reinstall the tube here. Alright, with my new clay loaded into the printer, let's run the extruder. It's time to start a real print. One thing I noticed is it started printing right away. There's no preheating involved. Alright, now we're getting somewhere. It looks like the first layers are the hardest to lay down, but once it enters into vase mode, it's actually pretty efficient. There's a large bubble entering the printer now that's going into that tube. When that gets to the extruder, it's going to pop. But I hope this little mug survives. My new clay formulation is a lot more consistent with printing, but I wouldn't push it this high. It was up to about 13 centimeters, and then it just collapsed all at once. This is very tragic, especially because this vase was looking awesome. Now if I wanted something like this to stand up at even higher heights, I could have a fan just blowing on this, and it would be drying the base out fast enough that it would probably be strong enough as it got up that high, and it wouldn't have collapsed. But it's too late for that. Alright, I'm going to start the next print. Alright, this one's actually looking pretty good. So the print just finished up, and I had my fan running the whole time, which was helping it dry off. But I noticed that it dried the bottom out here too fast, and you can actually see it started cracking. They're like puzzle pieces kind of stuck in there. It looks like the toothpaste consistency that I've been using is a little bit too soggy. When it starts to do any type of overhang, the whole thing just collapses. And if you don't know what I mean when I say toothpaste consistency, the easiest way to find out is to go to your tube of toothpaste You just squeeze it all out into your hand. Then just kind of squish it around in between your fingers. Alright, this is day 2 with the Tronxy Moore. I left all of this stuff submerged in water overnight just to prevent the clay from hardening inside of the nozzle. And here's the clay that I didn't successfully print yesterday. So I put it in a bucket here and added a little bit of water. You want to work as many bubbles out as you can, so just kind of pet it like this and get all those bubbles out. There's a device called a pug mill that'll squish these clays up for you, but usually you only have access to those at a larger ceramics studio. These layer lines look really good. The only issue that I can see is the bottom fell out. To address this, I think in the future, if I'm slicing my own models, I won't have it print this bottom area. I'll start with a nice strong slab of clay on the bottom, print this thing on top of it, and then trim around the outside when I'm done. As someone who's done a lot of ceramics before, I can tell you that this interesting surface texture is only going to look even cooler once you glaze it. It's a very cool artistic effect. And with the really soft clay that I was using yesterday, I was getting really consistent extrusion. The trade-off is that it was a little bit weaker, and on really tall prints it would collapse. The nice thing about clay is it's really easy to post-process. So let's say you actually didn't want these layer lines. Well, you can just come in here, rub your finger against it, and if you look at that, I just rubbed most of these layer lines off just with the texture of my fingertips. I can even get some of this slip mixture that I have in the bucket and just wipe it on here. So that did a couple of things. It got rid of the texture of the part, but it also increased the thickness. So if I wanted to make something thicker and stronger, I can just brush on some additional clay like that. They also sell colored clay, and just be able to paint on different colors however you want. This one also had an issue where the bottom fell out. You can see already this is laying down a huge bead of clay. That is actually insane. Probably way too much clay, to be honest. One of the settings that I adjust a lot is this Z height. When the printing starts, if I notice it's laying down too much material, I'll just increase the Z height to bring it up off of the table a little bit. So now we're on to the spiralized outer contour. I left the clips up here and it got in the way of the arm when it was trying to move over all the way to that edge. So it looks like it skipped some steps there, so I have a little layer shift. Uh-oh, looks like it's falling apart. This failure was mostly my fault. I had a really bad layer shift because when it got to the end, I had some clips being stored over here on the edge, and I bumped into those. But it looked like that print profile was working pretty good. Alright, here's the third day of experimentation with the Tronxy Moore 1. So today I'm just going to load up the clay. It's about a cream cheese consistency, so it's pretty stiff. I'm going to be using some hardboard. It's basically what you'd get if you took cardboard and put it in a hydraulic press. When you put your clay onto it, it actually absorbs some water out of the clay, and in that process it's actually adhering the clay to the print bed. I think this print surface isn't the best for allowing the part to shrink and contract in the right ways. So I'm going to try it out with the hardboard and see if I have any better luck with it. Tronxy recommends that you roll the clay into a cylinder and then drop it into this tube, but I'm going to try a slightly different method today. So first I'm going to take the clay out of the bag and I'll fold it over onto itself a couple of times just to get the texture to be more homogeneous, being careful not to work any air bubbles into the mixture. As long as you're folding it over like this, you have a pretty low chance of adding bubbles to the mixture, which is always just going to make your extrusions come out a little bit nicer. Instead of rolling it into a cylinder and dropping it into the tube, I'm actually going to just start shoving it in like this. So I essentially just stuck it through almost like you're taking a core sample of your clay blob. So I'm going to stack all the clay onto this again and just kind of push it on and keep repeating that process until I'm done. And now you can see there's virtually no air bubbles inside the cylinder. This is a near perfect cylinder of clay, so I shouldn't have any problems with bubbles as I'm printing this time around. Another thing I'm going to do is take a little bit of the clay out of the cylinder and mix it with some dried clay scraps that I have, just to have some slightly drier clay to work with. And I'm going to take this and squish it onto the hardboard by hand so that I get a nice first layer to build the rest of the print off of, which should mean I'll have less issues with cracking on the bottom. which has been kind of the biggest challenge that I've had so far with getting this printer to make complete parts. Now I've got my clay ball, and since I added some dry clay to it, it's no longer a cream cheese texture, it's more like cookie dough. So it'll hold its shape a lot better. And I'm going to smack it right in the middle of this hardboard. I also didn't clean the clay out of this or soak it in water overnight, just because I'm curious, if you do leave clay in this, how difficult is it to clean out? It looks like it's spinning easily enough, and I'm seeing little bits of clay fall out of it. I'm going to fill this cup up with water and just submerge it with it spinning like this, and I think that'll probably be enough to clean this thing out. Clay is pretty messy and it tends to clog stuff up, so this machine being able to self-clean and keep operating even if you're not really taking the best care of it is something that I really like having in a machine. Now I'm just going to submerge this in water. I also didn't clean the extruder out all the way. I just pulled the plunger all the way back and left it overnight. And we'll see how easy this is to refurbish and get it working again. I'm trying to unscrew it now, and it seems like the threads between the plastic tube and the aluminum are kind of seized up. Option number one is to dig out these screws and just undo these socket head cap screws. That'll detach this entire aluminum plate and plastic tube from this base gearbox. Then you can take that whole thing and dunk it in a bucket of water and get all the clay loosened up. And that'll probably take about 5 or 10 minutes to do. But I'm going to try a faster option, which is just to tap this with a hammer. And that should have loosened up those clay threads. Oh crap, I just cracked it. Alright, so yeah, you definitely don't want to do that. So your better option is going to be to undo these 4 screws and then just dunk the whole thing in a bucket of water to get all the threads loosened up. You just need to get in there with a screwdriver and clean out those bolt heads. I'm actually using a Torx bit because it punches into these clay-filled hex heads a lot better. So I'll just unscrew this whole assembly and dunk it in a big bucket of water to get that clay loose. This is more of a misuse and abuse case for this machine. Ideally, you should be taking this apart and servicing it before the clay gets all dried. I mean, that's just common sense with a machine like this. But it's nice to know that there's ways to disassemble it and restore it to working order, even if you were to neglect it a little bit. After letting this rehydrate for about 20 minutes, seems like everything's come loose again. I'm able to unscrew these threads quite easily. I guess the lesson learned there is to not hit this thing with a hammer. I know that might be common sense to some people, but yeah, I need a little help with figuring stuff like that out sometimes. I just took these panels off so that I can take a look at the main board. I'm finding that the stepper motor that drives the plunger is skipping steps. Now the stepper motor itself is cool to the touch, so it's not really working that hard. I just need to figure out which one of these stepper drivers is pushing that motor and turn up the current a little bit. I found the potentiometer that changes how much torque to send to that motor. It's this one right here. So I just turned up this stepper motor quite a bit. I'm not sure exactly how much harder it's working now, but I can tell it's pushing with a lot more force at this point. So you can boost the clay pressure, but you just set it down on the ground like this and push down on it. And that gives the clay a little bit of a boost in pressure. Sounds like it's starting to chill out, but it looks like it's working just fine now. I'm not sure why it was having so much issues before, but now it's just cranking through this like it's no problem. One thing I noticed about my print settings is this stepper motor spins a lot faster. It looks like it's actually printing a lot better because of it. I think I'm starting to get this printer dialed in. My prints are looking really good, and these are nice and thick parts printed with pretty dry clay. So I don't think I'll have the same issues with cracking that I was having before. Also, turning up the current to that stepper motor that drives the main plunger, I think was a big improvement. You'll notice the prints that I did on the first and second day are missing the base. That just fell out because it wasn't drying properly and the base was too thin. On the third day, all these parts I made by using the technique of laying down a slab and then printing on top of that. So now I have a really nice bottom on this part. You can see on the bottom it's really solid. So that's just kind of leveraging the advantages of working by hand and working with a 3D printer. Here you can see there's kind of a sharp corner right here, but I can just smooth that out. Oh shoot, oh no. Here you can see one of the vases that I printed today, and it's looking really nice. You can see a couple layer lines where something funny was going on there, but overall it's got really nice print quality. You can clean up these edges by cutting them, I have this screwdriver that came with the machine, and you can see I can just kind of chop this up and make the bottom edge continuous with the rest of the vase. That's one of the nice things about clay. You can just kind of fix any minor imperfections in the part and add nice textures or cut holes out wherever you want it. So there's just a lot of flexibility that you have by combining handwork and 3D printing. And the last piece that I made today was the spiral octagon part. So you can see inside here that the bottom is really nice and smooth. I'll wait for this to dry out a little bit more and put my finishing touches on it when it's leather hard. And then I'll have to set it aside and let it dry even longer until it's bone dry, like what these parts are. You can't really reshape these anymore, but you want things to be super dry before you put them into the kiln. Now we get to the firing stage. Okay, so this is a microwave kiln. You can buy these on Amazon, and it's probably the cheapest way to fire these parts at home. If you buy a traditional pottery kiln, that's going to cost anywhere between $300 for something really basic to thousands of dollars. Of course, if you have access to a pottery studio that has kilns that you can use, then that's your best option. You can just take this stuff into the pottery studio and have them fire it in a proper kiln, and you'll get the best results. But I'm hoping I can still get some pretty decent results with this microwave kiln. So it looks like it's just a really thick insulator with some material that absorbs the microwave radiation on the inside. This black material is going to get glowing hot inside of the microwave, and when this is all closed up, all that heat is trapped inside of this container with my clay part inside of it, and it cooks the part at over 1,000 degrees Fahrenheit. So I'm not using the microwave that I use to cook my popcorn and stuff. This is a special microwave that I bought for $20 on Facebook Marketplace. I'll just take this piece and put it in here. Alright, and enjoy the show. It's ran over 20 minutes. I'm going to take a peek in there and see how it's doing. Oh wow. You can see it's glowing hot. It's pretty crazy. So I'm just going to let this cool off for a while, and then we'll take it out and take a look at it. I've allowed this to cool off for about an hour, and it's no longer glowing hot. So I'm going to open it up and see what we have inside. Wow, that's really warm. That's really warm in there. Ooh. Really, you should let this cool overnight or something. It's really not worth getting in a hurry over this. So next time I think I'll just leave it out overnight to cool off really slowly. If you cool these off too... Oh jeez, what the... Okay, I'm gonna put this back on. Anyways, as I was saying, if you cool stuff off too fast, you'll get high thermal stresses, which can cause things to crack and pop apart. So I'm actually just gonna leave this put right now, and we'll let it just cool off on its own schedule. Sorry about that little ceramic guy. The heating material that is applied to the outside has a big crack in it, and that's probably from me opening this too soon. You definitely want to wait for these to cool off slowly. Now if we look at the piece in here, this has been sintered. It's like officially a fired ceramic piece. All of the water has been cooked out of this thing, and now all the ceramic particles have kind of solidified together, so it's much stronger. This isn't quite the same as a ceramic mug that you'd find, or a bowl, because it hasn't been glazed yet. So glazing is the next step in ceramics processing. Now just to be clear, you can leave your ceramic objects in this state, but one of the downsides is it's still porous, so it'll absorb water, and for that reason it's not food safe. It can absorb bacteria into the little pores in this material. You'll notice that any type of ceramic bowl, plate, or cup that you eat out of will be nice and smooth and shiny, and that makes it really easy to clean. Clay that's in this state is kind of porous, and it's difficult to clean since there's not a smooth surface. You can't just wipe stuff off of it. I mean, imagine if your toilet was made out of this kind of ceramics. Wouldn't be a fun time. But it still looks great, and if you're just making decorational pieces and you don't mind the matte texture, then you can leave it in this state. But I'm going to take this piece to the next step, which will be to apply some glaze to it. I fired one more piece here. It's looking pretty good. I ended up using this glaze that I bought on Amazon for this piece, but it's not the type of glaze that I'm used to. This is actually a glaze that doesn't require any firing. It's basically a clear paint, and I'm not really a big fan of this. I'm more interested in the types of glazes that you put back into the kiln and then you fire, and they cause all sorts of crazy chemical reactions and make all sorts of interesting colors. Up to this point, I'm really impressed with the results I've been able to get with this Tronxy Moore printer. I've got 2 fully fired pieces, and I've got a couple more that I'm still working on. I carved the base of this octagon cup, and it's looking pretty sweet now. And then on my 2 vases, I did 2 different style bottoms. The one on the right, I carved it to be continuous with the rest of the curves of the vase. The one on the left, I left more in like a raw state, so it kind of looks like it was carved out of a chunk of stone. But here's my final thoughts on the Tronxy Moore 3D printer. I think it's really awesome that you're able to get a clay 3D printer for such a low entry point. Even though my printing experience wasn't perfect right out of the box, I think that it's a great platform because it's made out of durable parts that don't require a lot of maintenance. It takes some trial and error and technical skill to get working, but so does everything else in clays and in 3D printing. So I wouldn't let the learning curve discourage you from getting into clay 3D printing. If you're someone like me that has a background in pottery and 3D printing, then I think you'll find this to be a really fun intersection of 2 of your favorite hobbies. And that's what it's been for me. I haven't been in a ceramic studio for a while, so being able to get my hands in the dirt again has felt really good. I'd also recommend it for ceramic studios that are part of high schools and colleges, because you've got a lot of kids there that are really into technology and really excited to learn new things. So having a clay 3D printer around, I think, is something that could really get them interested in the hobbies of ceramics and 3D printing. I wouldn't recommend this as a first 3D printer unless you already have a background working with clays and pottery. It's not quite as easy to get going as a typical FDM plastic 3D printer, but the capabilities of this machine and the ability to make parts out of clay, I think that's just super unique and cool. Also, if you're a professional potter and do ceramics for a living, I think this is a really cool tool to get because there's a lot of creative effects you can do by having the ability to make such complex geometry. I'm just barely scratching the surface of what you can do with this machine. Everything that I've printed has been in vase mode, but there's nothing to say that you can't print out like a benchy with this thing once you get it tuned in well enough. Also, there's different things you can do with clay formulations, like adding plasticizers and other additives that'll help the clay hold its shape and still be easy to extrude. So I'm really excited to see what's possible to be done with these machines. The other really interesting connection you can make with this machine is it's really similar to those concrete 3D printers that are building houses. So if you want a little taste of that technology and you want to know what it's like to print with a concrete 3D printer, this is probably the closest thing that you can get for under $1,000. I'm going to save glazing for a future video, and I'll probably be doing other kind of weird experiments with this printer. So if you like this content and you want to see more like it, make sure to subscribe to the channel and like the video and ring that notification bell too while you're at it.